2 and switch 4 are on. 2 is on, 4 is on. That's going to create a short circuit against the load. That's why the voltage is 0. Now we're going to go back from state 4 back to state 1. So from state 4 to state 1, we want to keep switch 2 on, but we want to turn 1 off and 4 on. So again, before turning 1 on, we keep it as off, right? We turn 4 off, right? Then we're gonna turn 1 on. So this is the middle state that we have here between 4 and 1. So this is the dead time that we're gonna have here. So in this case, switch 2 is on. This switch is on. Sorry, this switch is on. Okay. Again, we're gonna assume both directions for the current. If the current is going this way, which diode is gonna conduct, 1 or 4? Of course 4, because this is the direction of the current. This is gonna conduct. So what is gonna be the voltage that we have across the load? So like the path, it's gonna be from this diode 4, it goes to the load, it goes back to this switch, and this is what we have. It's a short circuit, but we have a voltage drop against the diode. The voltage that goes across the load, it's going to be negative VFD. Okay, if the direction of the current is from this point to this point, then again we only have switch 2 on, so this is conducting, and if the direction of the current is this way, now this diode is going to conduct. Okay, so the path for the current, it's going to be from this switch to the load to diode 1, goes back to the source, it goes back to switch 2, and this is like what we have for the path for the current. What's the voltage here? Let's assume that this is 0. Okay, this one, it's gonna be connected to VDC, and this one, it's gonna be VDC plus VFD, because if this is VDC, this has to have a voltage higher than VDC because of the voltage drop of the diode. So this is gonna be VDC plus VFD. Oh, okay. So if I want to draw this again here, I have created this delay times or dead times here. So you see that like here before 1, like 1 is supposed to go off and 4 is supposed to go on, but we just have it like with a delay. Okay, so now we're gonna see what happens to the previous signal waveform that we had. So let's just like see what's gonna change here. So in this part, nothing is changed, right? Switch 1 is on, switch 2 is on, but in this point, only let's look at the switches. Only switch 1 is on, right? Only switch 1 is on, right? I'm only gonna do the red ones. Okay, so I assume that the direction of the current is always this way. You can just do the green ones later yourself. So if that's the case, switch 1 is on and the other switches are off. So the voltage across the load, it's gonna be negative VFD. Okay, so negative VFD, let's assume like negative 1. So it's gonna be a very small voltage. So it's gonna be something like this. Right? Now here, again, we have switch 1 and switch 3 on at the same time, so the voltage is 0. Then the dead time, it's gonna come, so switch 3 is on, the other switches are off. Switch 3 is on, the other switches are off. The voltage across the load, it's gonna be negative VDC minus VFD, right? So it's gonna be something like this. Okay, so this is what's gonna happen. Negative VDC minus VFD. Okay. Now, what's the next dead time that we have? So here we have switch 4 and 3 on at the same time. If that's the case, 3 and 4 on at the same time, we have negative VDC. Okay, so what we want to do now, let me just actually do this a little bit better. What we want to do now, so from this one to here, we want to turn 3 off and 2 on, right? So we keep 4 on, but we turn 3 0 first. We turn 3 off. So this is the dead time that we have. Only 4 is on. This is this state 3, the red one. So only 4 is on. So when 4 is on, this is the voltage that we have across the load. So it's similar to what we had before. It's going to be negative VDC minus VFD. Okay, and then we can turn 2 on. So 2 on, 4 on. This is what we have. We're going to have when 2 and 4 are on, we have a short circuit. So that's why the voltage is 0. Another dead time. We want to go from this state to this state, right? So we want to turn 4 off and turn 1 on. Before doing that, we turn 4 off, right? The only switch that we have on in this dead time, it's going to be switch 2, right? If you look at this dead time here, only switch 2 is on. When switch 2 is on and all the other switches are off, we have negative VFD here. So this is going to be negative VFD, and it goes back to what we had before. And this is going to continue. So these are the effects that we have because of those dead times. Okay, so why did we have to do this? Because we never wanted to have these two switches on at the same time. Even if you use like microcontrollers to give signals to these gates, it's impossible to have two switches on at the exact time. They're gonna have some delay, microsecond, nanosecond, and that's gonna cause a problem. It's gonna cause a short circuit, and it's gonna blow up the switches or the cables, the wires, the load. Many things gonna happen, right? So to avoid that, to transition between the states, we created dead time, the delay, right? So before turning like on something, we keep it off, right? So like let's say like here we wanted to turn 2 off and 3 on, right? So this dead time is created when we turn 2 off, we kept 3 off, and then turn the 3 on. So this is the practical solution for avoiding two switches on the same leg on at the same time. Now, the problem or that we didn't discuss was like how to actually create this gate signals, gate voltages to turn these switches on and off, right? So that's the topic that we have to discuss a little bit later. That's called modulation. It's